My name is Jeff Donato. I'm the Director of Safety Products with H2scan. Today we're going to talk about managing hydrogen risk with battery-powered forklifts. So forklifts contain electrolyte, which is a sulfuric acid and water solution. And during the charging process, hydrogen is emitted through the vent caps on top of the battery system. So during the charging process, electrolysis occurs and water is split into the component gases, which is hydrogen and oxygen. And hydrogen is released through the vent caps on top of the battery. This is the same vent caps that you use when you water the battery. And so hydrogen is released through those vents and it can accumulate on the ceiling since hydrogen is lighter than air. It could collect on top of a ceiling, or it could collect in pockets, or if there are raised parts of the ceiling, and can create hazards. Hydrogen becomes flammable at 4% and remains flammable all the way up to almost 70 or about 76%. This is why we have a lot of codes and standards that require facilities to keep hydrogen at a reasonable level. All of the codes and standards in the US say that we need to keep hydrogen below 1%. So this provides a 4-to-1 safety margin. This is also being adopted around the world as codes and standards change to provide this safety margin when dealing with hydrogen. Lead acid batteries are not the only batteries on the market, and there are other batteries that have different gassing properties and also much faster gassing that happens if a battery were to go into thermal runaway. So even though this particular presentation isn't about lithium batteries, just for example, lithium batteries gas a whole lot faster if it were to go into thermal runaway compared to lead acid batteries. Keep that in mind. That's why these safety standards exist, so that you have time to react to a situation. And hydrogen is very unstable. So even if it's a light or a switch, it can ignite hydrogen very, very easily. Codes and standards have a requirement for mitigating hydrogen. So the most popular, of course, is mechanical ventilation. This is where we install fans towards the ceiling and pull air through a room and evacuate the hydrogen that way. Interestingly enough, though, unless you have redundancy in your mechanical ventilation or you have another plan to mitigate any kind of failure with those mechanical devices, oftentimes the authority having jurisdiction wants you to have some other form of backup in case you do have a ventilation issue. And so this is where active gas monitoring comes into play. And these are installed at the ceiling. Obviously, as I mentioned before, hydrogen rises very rapidly. And so we install gas monitoring at the ceiling to trigger alarms. We don't want to install them close to the charging area. Like, we don't want to drop them down from the ceiling so they hover above the charging area, because then that would just create a lot of false alarms. So we want them very high. And then also we want them to do something. So it could be an audible alarm and a visual light if you want to have just the basic kind of system where it says, I have hydrogen in the area, so it's going to activate these alarms and alert you to the fact that hydrogen is present. It could also be connected to the fans to activate fans automatically as part of your mitigation strategy. And also it can connect to the charger itself to provide charger shutdown, or you can provide the shutdown to the whole charging circuit. And so this means that if hydrogen were to rise above 1%, maybe it could trigger a fan. And then maybe if you have a second alarm that says, okay, this is more critical, it's even rising further, then it shuts down the whole system. So you can have multiple phases when it comes to the different levels of hydrogen and working within that 4-to-1 safety margin. We also want to prevent building hydrogen sulfide. So hydrogen is lighter than air, and this is the first gassing that happens out of a battery. But if a battery continues to be overcharged, then it could produce hydrogen sulfide. This is where basically you have two hydrogen molecules binding with one sulfur molecule, so you have hydrogen sulfide. Because it has that composition, it is heavier than air and sits mostly towards the floor, and it's a heavier gas. And the H2S is the symbol for hydrogen sulfide, so I'll refer to that in this presentation. It smells like rotten eggs when you walk into a room, It's highly toxic and corrosive, so it will give you a scratchy throat if you breathe it in, and it can eventually make you very sick. And so we want to avoid this scenario as well. So monitoring for hydrogen also helps us avoid, or identify rather, that you have a serious overcharge situation that could turn into H2S. So how does hydrogen gas become dangerous? Just an overview. I created this little AI graphic for us to show the process. Batteries are charging, and this could be in charging directly from the forklift truck, or it could be charging from a multi-battery charging bay. Either way, the electrolysis happens inside of the battery, emits gas, and then of course we have this sealing space that we have to monitor. Most of the time, again, per OSHA regulations and per fire code, you have to evacuate the air in that sealing. So you have safety fans that are running pretty much nonstop. However, if you have a fan failure or hydrogen accumulation exceeds the amount of airflow that to evacuate those gases, then it could go into the LEL, or lower explosive limit. And so this is just the 4% where hydrogen becomes explosive. And then the consequences are you could have explosion or fire. We have had reports on where the explosion is so great it damages a ceiling or a wall, and could even injure personnel. And so our safety solution is to ventilate the room, monitor hydrogen gas, and then of course make sure that your batteries are well maintained. Make sure they're topped up with water, because as the plates are exposed to air, if they're not properly maintained, will create more hydrogen gas. And so also safe practices, making sure you have the correct safety signs in place and the correct training for your personnel, and making sure that no open flames or smoking or anything happens inside of these areas. So this is a shared risk and responsibility. So you're an owner or an operator or a facility manager, you're responsible for what I just described, making sure your facility is set up to mitigate the hydrogen in the room. But also, fire marshals and authority having jurisdiction personnel also have the responsibility for enforcement and keeping the community safe, and making sure that we have defensive systems so that we are protecting people and protecting buildings. But the engineers also that design these spaces also have a responsibility to make sure that they're following current codes and regulations and best practice standards, and making sure that they are in compliance with the current regulations. This also means that it's not a one-size-fits-all. So you could have a charging area in a very wide space and meet the 25% lower flammability level or 1% of hydrogen requirement and be fine. But as soon as you put those forklifts or charging areas in a confined space, then the authority having jurisdiction might require you to lower the amount of hydrogen that's permissible in that area, just to avoid any kind of fast accumulation. It's also, as far as facilities managers, making sure that systems are maintained and that uptime is the most important when it comes to not only the forklift equipment and the batteries, but also worker safety, and make sure that the safety systems are also properly maintained. And then, of course, making sure that we understand the codes that affect each area. So as we move from state to state, these codes and regulations can change, and also as we move from city to city. So there are slight variances in the way different jurisdictions handle code compliance. And so make sure you understand what is required in your area. So this slide just shows a few different things we talked about when it comes to charging. You can see that to the first picture, we have a typical forklift charging station with the batteries left into the fork trucks and they're plugged into the chargers. And then you, of course, have your changing station where you're removing batteries and putting them into a charging area. Obviously, the forklift charging and changing stations will produce more hydrogen just because of the nature of the fact you're charging more batteries at once. Also, in larger production facilities such as auto plants and some other 24/7 operations, they've moved to fuel cells rather than batteries. And it's basically where they take the battery out and put a hydrogen fuel cell in the truck to power the electric truck. So it basically converts hydrogen to electricity. And in this case, they have fueling stations, and hydrogen can emit from the fueling stations. Leaks in the piping can actually have leaks as the truck is operating. So we have to also measure for hydrogen production in these applications. And one thing I'll mention in any of these applications, and we'll mention it we'll also mention it later in this presentation, is the fact that hydrogen will confuse a carbon monoxide sensor. So if you have carbon monoxide sensors near the area and they happen to be going off, that could mean that it's actually reading hydrogen and not carbon monoxide. So then you would have to have both sensors to figure out whether it is hydrogen or carbon monoxide. Because carbon monoxide sensors are very basic TCDs or MOS sensors that can't distinguish between hydrogen and carbon monoxide. They just know that there's a toxic gas there. So in those cases, what we see is the facility management would put a hydrogen sensor and a CO sensor next to each other. I mentioned earlier with the various battery technologies, we have valve-regulated lead-acid batteries and vented lead-acid batteries, which can be found in various fork trucks and pallet jacks. NiCad batteries, we've seen these in some automatic guided vehicles, and then of course lithium-ion batteries, which are very high-powered batteries for very intense applications. So all of these have hydrogen risks. It's just depending on when they occur. So in the top section, with any kind of lead-acid battery or NiCad battery, hydrogen will be present as a normal gas that emits from the battery. Now, valve-regulated batteries are mostly recombinant, but if you overcharge them, they will release hydrogen. Vented lead-acid batteries, or VLA batteries, will emit hydrogen naturally as they charge. And then NiCad batteries will also, they're just like vented lead-acid batteries, except they're NiCad and they're also vented. So instead of a lead-acid battery, you have an alkaline battery. Lithium batteries have no hydrogen that really comes out of it during normal operation, but if you overcharge the battery and they actually go into thermal runaway, then the vent gases can be released, and that's the beginning of thermal runaway. And about 50% of those vent gases would be hydrogen. And so you have a hydrogen risk there only in abnormal operations. So as I mentioned, hydrogen is odorless and colorless unless it turns into hydrogen sulfide, then smells like rotten eggs. But it's very easy not to be able to detect hydrogen without the proper instrumentation. And again, as I mentioned, very wide flammability range. And it also migrates upward and collects in ceiling pockets, mezzanines, enclosures, and for this reason can become dangerous. So authorities having jurisdiction, such as your building inspector, fire inspector, have a lot of interest in this just to protect people in the facility. Commercial insurance carriers also have a big interest in this. For example, FM Global is the largest commercial insurance carrier in the world, and they have written many supporting documents to how hydrogen should be dealt with in their facilities. And also for facility engineers and building owners, ventilation can't be the only control. You have to have some sort of backup. We have seen many instances where ventilation systems are either not adequate enough or they have failed because they are mechanical devices. And this could be the louvers on the outside of a facility. It could be the fan doesn't maintain the correct airflow that it needs to maintain, or it could simply stop working. So while fans are your primary defense against hydrogen buildup, sensing should be also installed. And they can be installed together. Again, you can use sensing to activate fans or to activate additional fans or increase a facility's HVAC system to maximum output so that it moves air around so that hydrogen doesn't have the chance to accumulate into explosive mixture. So there are lots of different standards documents as well as code documents that exist. International Fire Code is the most popular model code for fire codes in each state. And then, of course, you have OSHA and other governing bodies when it comes to safety of people. So for engineers who are designing systems, you have international standards such as the IEC and also IEEE and ASHRAE documentation for ventilation methods and how much ventilation should be passed through an area to mitigate the hydrogen based on the number of batteries and battery types that you have. For facilities and warehouses, of course, OSHA and fire code basically set the requirements for making sure that combustible gas isn't accumulating in areas, and also that employees aren't being poisoned by H2S as well. And then, of course, OEMs, the equipment manufacturers, have to provide equipment that can be integrated with these systems, and so safety systems can function without the interaction of an employee or facility management. So this is a graphic about all of the fire codes that you would have to consider with your forklift charging area. So you have NFPA 1, you also have the International Fire Code, the mechanical code for the ventilation fan, ASHRAE standards, as well as FM global data sheets. All these play somewhat together in this space in making sure that you keep the proper ventilation and also keep hydrogen gas concentrations below 1%. So with forklift and warehouse operations, just keep in mind, if you're charging batteries in forklifts, you have hydrogen. And so it is our responsibility to make sure we're mitigating these risks, and also the fire marshal and the facility manager kind of work together in making sure that the proper systems are installed and making sure they're maintained properly. So as we renovate and add equipment and changes, we have to make sure our airflow is correct, our airflow patterns are correct, and making sure that we have proper mechanical ventilation and detection. And as fans age or fail, we have to make sure that those are maintained and replaced as well before there's an incident. So making sure that our equipment is in the proper life cycle is very important. But what do inspectors want to see on site? They want to see documentation. Pretty much all safety standards, model codes, adopted codes, basically all say the same thing. They want you to operate in a safe range. They want you to prove that you have a mitigation plan for controlling hydrogen or any kind of safety risk. And they want to know what your action's going to be when an alarm goes off, and make sure that you're taking an appropriate response, or the system is doing an automatic response, either way. And so test logs and alarm history, maintenance records, all these are basically required to keep on site in case the authority having jurisdiction would like to inspect those. And it really helps when you have smart systems. Today we have the ability to have safety systems such as sensors that have self-diagnosing capabilities and also self-calibration capabilities, so that they're doing all these things automatically, so that you don't have to worry about it. And as long as it's built properly with the self-diagnosing characteristics, it will alert you if something is not operating correctly. There are so many sensors out there that could have blocked signals, so the green light is on saying it's operating properly, but it really is not, so because the signal's been blocked. So choosing a sensor that actually has these diagnostics is very important. And also to choose sensors that eliminate cross sensitivities and are specific to the gas you're trying to monitor. So in this case, hydrogen sensors can also detect a lot of other gases if they're just a general gas sensor. But with, say, for instance, the H2scan sensors cannot detect other gases. They are specific to hydrogen. So you can expose them to CO, you can expose them to other gases, solvents in the facility, and it won't react because it's not hydrogen. And also knowing the maintenance schedule for the sensors and making sure hydrogen monitors have the right replacement parts. So in this case, there are many sensors out there that require replacement parts and calibration. And then there are others like ours that are solid state that require absolutely no calibration and no replacement parts. So choosing the right sensor is very important to make sure that you've your sensor meets the requirements of your maintenance staff. Many facilities don't have maintenance staff that really know a lot about maintaining sensors, and so having a sensor that maintains itself is very important. And we can basically provide that simplification for your operation. So that's where H2scan comes into play. We have hydrogen-specific solid-state sensors. There's no cross-sensitivity to other hydrocarbons or any solvents or anything of that nature that would create any kind of nuisance alarms. So we've eliminated all of that. Our sensors have over a 10-year life. There's no calibration, there's no replacement parts, and there's nothing you have to do to it over its service life. It's fast, it's accurate, and you can have a lot of different things in your environment, but it will only detect the hydrogen in the air. This means for inspectors, it's a high confidence. You don't have false alarms going on that you have to respond and log these events. For engineers and OEMs, it's something they can set and forget, and they don't have to worry about customers calling back to them saying this sensor is malfunctioning, or not functioning at all. So this is a very, very reliable system. And for facilities, there's nothing draining your maintenance budget or creating an unsafe situation where maybe personnel have to get up on ladders or lifts, or having to maintain sensors that are high on the ceiling, causing safety issues with OSHA. Because I actually came across a facility the other day that OSHA said that the way they were trying to maintain their sensors by standing on very tall A-frame ladders without fall risk, they said they couldn't do it. So they had to basically shut the sensors off and buy sensors that had automatic calibration, as well as no maintenance and no replacement parts. And so that solved their problem with having an unsafe environment, with them crawling on ladders with hydrogen calibration bottles and trying to do maintenance throughout the year. So we've solved all these issues for the industry. We also had a case study I mentioned earlier in the presentation where a large automaker deployed hydrogen fuel cell forklifts, multiple fueling stations in their facility. I think it was like a mile long. It was a pretty impressive setup. So the local fire department came up with their handheld CO sensors and reported that they had higher CO levels than what they were expecting. And so they were using a technology that were cross-sensitive to hydrogen, which is very common. You won't necessarily find a lot of CO detectors that can separate CO from hydrogen. So as a result, they installed our hydrogen sensors, which are hydrogen specific. And so now they know if it's CO or hydrogen that they're seeing. And they connected it to their building system, which they ramp up fans based on the hydrogen level. So that was a very good example on how nuisance alarms or false alarms can create a lot of havoc inside a facility. And so knowing what you're sensing is important, especially if your detector can sense multiple gases. So this was a good outcome for this situation. So we have a couple of different models with this technology. We have the 5020, the 5021 series that are general location sensors, general to any hydrogen safety application. The sensor speaks Modbus RTU and it's very simple to operate. It is an analyzer, so it just gives you the data, and then you can connect this to your building management system to create your alarm set points. Then we have our newest sensor, which is the HighGuard. The HighGuard is an all-in-one unit. It has all of the communication platforms built into one unit. It also mounts to a standard J-box, which makes it very easy for installation. It has Wago connectors that you can basically strip the wire and put the wire in and flip the tab down, and it is secure. And so that way there's no tools to actually connect your power and communications. So it has AC and DC inputs. It has audible alarms. You can also have other mounting options such as DIN rail, magnets, wall mount, those types of things for this unit. So it is an all-in-one unit that is very popular in the battery industry. Actually, the battery industry helped design this unit to the specifications that they need, but it also does very well for most all safety applications in which you're trying to detect an accumulation of hydrogen. So this is a general location sensor. So if you need Class 1 Div 1, Class 1 Div 2, or those kind of intrinsic safety applications, we have sensors that meet those requirements. So this has a safety certifications for electrical safety, and it's, like I said, very popular in battery rooms, data centers, and also energy storage containers. That's the presentation. And if you have any questions, my information is on the screen here. There's my email and my phone number. Feel free to reach out, send me an email or a text. I would be glad to answer any questions you may have. Thank you very much.